This is Sharon White from Dr. Grzinski's class, and I'm redoing a problem from test 1. So the problem I was given was the series from 3 to infinity of 2 raised to the 3k minus 1 over 9 to the k plus 1. So the instructions were to use a convergence test to see if the series converges. So the test I chose to use was the ratio test. And with the ratio test, basically you take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n, and that's going to equal p. So for the ratio test, it's important to remember that if p is less than 1, it converges. If p is greater than 1, it diverges, or if it's infinite, it diverges. And if p is equal to 1, then you have to use another test. So with that, you just take a sub n plus 1 and you put it in for k, and then you take a sub n and you also put that in for k. So going back to the original problem, I'll plug that in now. So I'll get the limit as k approaches infinity of 2 raised to the 3k plus 1 minus 1 over 9 to the k plus 1 all over, and then you plug in sub n, so you'll just get 2 raised to the 3k minus 1 over 9 raised to the k plus 1. So for this part, for the n plus 1, the sub n plus 1, I like to put it in parentheses because it lets you remember to distribute the 3 to both the k and the 1. So now I'm going to simplify. You're going to get the limit as k approaches infinity of 2 to the 3k plus 3 minus 1 over 9 to the k plus 2 all over 2 to the 3k minus 1 over 9 to the k plus 1. And this is going to equal p. So now it's important to remember the exponential rules, and you can simplify this into 2 to the 3k times 2 raised to the third power. So I'm going to do that now for both these two. So you'll get the limit as k goes to infinity of 2 raised to the 3k times 2 to the third power minus 1 over 9 raised to the k times 9 squared all over 2 raised to the 3k minus 1. You can break this up to over 9 to the k times 9 to the first power. So now you're going to, of course, fix the fraction because you have a fraction over a fraction. So I'm going to simplify that. And you'll get the limit as k approaches infinity, and you'll just simply multiply this top fraction by the reciprocal of the bottom fraction. So at the top, you'll get 2 to the 3k times, we could go ahead and simplify this, times 2 raised to the third power is 8 minus 1 over 9 to the k times, I'll just leave that as 9 squared, and then the reciprocal of this bottom half would be 9 to the k times 9 to the first power over 2 to the 3k minus 1. So right here you can see we have some similarities, so we can go ahead and cancel, because the 9 to the k and the 9 to the k will cancel. and then 9 squared and 9 to the first power. The 9 to the first power would cancel, and this squared would cancel. So you'll just have 9 at the bottom. So now, this leaves us with, I'll draw an arrow. We'll have the limit as k approaches infinity of 2 to the 3k times 8 minus 1 all over, we still have the 9 at the bottom, and then the 2 to the 3k minus 1, so it'll be 9 times 2 to 3k minus 1. So we can go ahead and rewrite that down here and put the coefficients, the 8 and the 9, in the front. So we're going to take the limit as k approaches infinity of 8 times 2 to the 3k minus 1 over 9 times 2 to the 3k minus 1. So you can actually take out the 8 over 9, but you can tell from this point on that when you do k to the infinity, these two will cancel because the coefficients are the same. I mean, the powers are the same. So actually, when you take the limit as k approaches infinity, these two, since they're the same, they'll pretty much cancel. So they don't really matter. So actually, the answer would be 8 over 9. So the limit as k approaches infinity of this right here would be 8 over 9. And since 8 over 9 is less than 1, with the ratio test, this is going to converge. So the final answer, if we go back to the original problem, since all of this work shows that this final limit is equal to the one that was at the top, so you would just say that the series from k equals 3 to infinity of 2 raised to the 3k minus 1 over 9 to the k plus 1 is equal, the limit of this is equal to 8 over 9, and that's less than 1. So the series converges. Thank you.